Hello everyone, this is Shrejal Yadav from EC third year. My roll number is 23104079. Today I will be explaining a very interesting topic of Klystron tube. Specifically, I will be explaining the working of two-cavity Klystron amplifier. So let's start the video. Klystron tube was invented by Russian and Sigurd Varian in 1937. If you are wondering what is Klystron tube, then Klystron tube is basically a microwave tube that helps in transmitting signal over huge distance. It works on velocity modulation and used for amplifying high frequency signals. Our main topic, two-cavity Klystron amplifier. First, I will be covering basics about two-cavity Klystron, then I will explain structure and working of two-cavity Klystron amplifier. So Klystron tube is a vacuum tube. It is used as amplifier and oscillator at microwave frequency. The microwave frequency range varies from 0.3 GHz to 300 GHz. It works on the principle of velocity modulation. I will be explaining all the points when we will discuss about the structure of two-cavity Klystron. It has two cavity. As the name suggests, two-cavity Klystron, it has two cavities, the buncher cavity and catcher cavity. Input is applied to buncher cavity and output is received from catcher cavity. Now we have reached to the most interesting part of the topic, that is the structure of Klystron tube. So this is the Klystron tube. The cathode or electron gun is attached to negative potential of DC voltage, while the anode or collector anode of Klystron tube is attached to positive potential of DC voltage. It has two cavities, buncher cavity and catcher cavity. The RF input is applied at buncher cavity, while the RF output, the amplified signal, is received at catcher cavity. The space between buncher cavity and catcher cavity is known as drift space. We have segregated the electrons emitting from electron gun into three categories. They are early electron, reference electron and late electron. The first category, the electrons that are emitted early from electron gun are known as early electron. Electrons emitted after early electron are known as reference electron, and the electrons emitted at last are known as late electrons. So this was the structure of Klystron tube. Coming to the working of Klystron, two-cavity Klystron, we will discuss the working in three cases. The case one is when no RF is applied. So when no RF signal is applied, then all three categories of electron, that are early electron, reference electron and late electron, will move with uniform velocity. Because no RF input is applied, so there's no electric field to hinder the speed or motion of the electrons emitting from electron gun. Thus, all three categories of electron will move with uniform speed in case one, when no RF input is applied. Coming to case two, when RF signal is applied with negative cycle. We all know that signal have two cycles, the positive cycle and negative cycle. If we are applying the RF input at negative cycle, then in that case the accumulation of charges will be like the negative charge will be accumulated on this side of the buncher cavity. This is buncher cavity and this one is catcher cavity, and the positive charges will be accumulated on the other side of buncher cavity, and hence the direction of electric field is in the opposite direction of moving electron. So for example, the early electron which was moving in this direction gets hindered by the electric field which is in opposite direction of its motion, and hence the speed of early electron will be reduced because of the opposite direction of motion of electric field. I have written the same point here. It creates electric field opposite to motion of electron. So electron velocity, especially the early speed of early electron, get reduced. Now the third case, when RF signal is applied with positive cycle. Here, when RF signal is applied with positive cycle, then in that case, the accumulation of charges will be radically opposite to as it was in the negative RF cycle. So the accumulation of charges will, the positive charges will accumulate on the left side of buncher cavity, and negative charges will accumulate on the right side of other side of buncher cavity. So the direction of electric field will be in same direction as of motion of the electrons emitting from electron guns. So for example, the late electron that is moving in this direction gets affected by electric field in drift space, and because the electric field is in same direction of motion of late electron, thus the speed of late electron is increased. I have mentioned the point here as well. It creates electric field in same direction of electron flow. Hence, the velocity of late electron will be increased. So, summing up the working explained in all three cases, we have learned that according to positive and negative cycle of RF input, we can increase or decrease the speed of electron emitting from electron gun. The all three categories of electron, early electron, reference electron and late electron, superimpose to make a bunch which act as amplified signal which is received at catcher cavity as RF output. Coming to the Applegate diagram, I have already drawn the diagram. Here, this depicts the positive cycle of AC voltage, and this is the negative cycle of AC voltage. Here, I have written the all three electrons: late electron, reference electron, and early electron. The late electron was early electron was implied with the negative RF input. Reference electron was implied with no RF input, and late electron was implied with positive RF input. So according to that, the time taken by early electron to reach the destination was higher than reference, and time taken by reference electron to reach the destination was higher than late electron. So late electron are the ones who reached fastest among all three, and the early electron were the one who reached at last among all three. Coming to the last topic, that is applications. So Klystron provide high gain, so it is used in satellite communication, and it is also used in pulse radar. Thank you. This was all I wanted to explain about two cavity Klystron tube.